just gonna talk about my understanding of the problem rather than talking about or just coding everything through. Because I feel like the key thing to realize here is like some mathematical intuition rather than some code uh, implementation understanding. Um, so you're given a grid, and in this grid there are numbers, and you want to choose some value such that it minimizes the distances between the elements of the grid and that value. Um, so like let's go through the first example. We have 2, 4, 6, 8, and then the output is 4. Um, basically, an operation is, what is an operation? You can add x or subtract x from any element in the grid. And in this case, x is 2. And you want to, I mean, the operation is basically, it's kind of just like figuring out the distance from a specific value. But like the units are in x. Yeah, so basically it's still like thinking about the distance between the element and the value that you choose, and you want to minimize the distance, or I guess in this case the operations. Yeah, so the key thing to realize here is that it doesn't really matter whether it's in a grid or not. And then you can just like sort it into a flattened list. You could have 2, 4, 6, 8. And then you could kind of visualize it on a number line. And then you realize that if you choose like a value that's not in between any of these values, then obviously that can't be the value that minimizes the operations or distance. I'll just say distance because it makes more intuitive sense to me. And then like when you put it in between two values, you realize like if you shift the value that you choose anywhere between the two values of the grid. So say like, okay, I need like Excalibur or something. Okay, so say you have like this number line, and then you have shoot, you have this value, this value, this value, this value. Actually, let's just use 2, 4, 6, 8. So 2, 4, 6, and then, oh my gosh, it's taking forever. 8. So you have 2, 4, 6, 8. And then let's say you want to choose, this is like the value that you choose. Let's make it red. Okay. Then anywhere in here where you put the value, of course it needs to like be reachable by x, by units of x, but like anywhere you put this value in between, like it doesn't matter because I mean it has the same distance, because if you make this distance, if you move this way as opposed to like this way, then like the distance between 4 and that value increases, while distance between 6 and that value decreases. So like it kind of cancels out anywhere you put this red line between 4 and 6. And same thing with like 2 and 8. Like if you put this value here, then 2 takes less distance to reach the red line versus 8 reaching this red line. Like it increases, but it cancels out. So like it doesn't matter where you put this red line in between here, as long as it's reachable by x steps for all the values, by kx steps, where k is some integer. Okay. And then I guess I think I still don't understand the mathematical intuition. Like, because you want to find the median. Why do you want to find the median? Okay, so I think you want to find the median because if there's, let's say we have 2, 4, 5, 6, 8. So you want to choose 5 because, like, if you choose 5, 5 doesn't have like a corresponding pair like 4 and 6 and 2 and 8 do. Um, so then if you just choose the median 5, okay, let's just draw it in. And let's make this black and let's add 5. So if you put this red line at 5, then 5 doesn't need to move anywhere. So like it decreases the amount of steps, um, minimizes the amount of steps. So I guess if you have an even number uh, in the grid, even number of numbers in the grid, then it kind of doesn't matter which value you choose as the red line. But if you have an odd number of values in the grid, then you want to choose the exact median because then you don't have to waste some extra steps if like um, yeah, you don't have to waste extra steps because the median is already at the middle element, or the value you chose, the red line, is already at the middle element. Okay, yeah, so that's my intuition. Okay, that's it. So yeah.